Good morning. Welcome to the FOSDEM Lightning Talks. Great to have you all here. Yeah, let's have a round of applause to start. Thank you everyone for coming. So, my name's Sam. I'm going to talk about testing GNOME mobile images. I guess everybody here has a smartphone, right? Anyone not have a smartphone? Nobody. And you're probably aware, with this being FOSDEM, you're probably aware that the US tech industry controls most of the available phone operating systems at the moment. So we're quite interested in alternatives, right? In fact, there's a whole dev room happening this afternoon, the FOSS on mobile devices dev room, on this exact topic. So hopefully I'll get you interested to join in there. So what alternatives are there? If you want to have a phone which is controlled by you, and which is all open source, there's a few different technology stacks. Probably the most obvious is Android itself. The core of Android is still open source, even though a lot of the bits you need actually are closed source and owned by Google these days. But the core of it's open source, and there are people working on replacing the proprietary Google bits with something open source called micro G. So one option is Android, and there's things like EOS and Graphene OS, which you can use. And then the rest is kind of, in the open source world, we always have different flavors for different tastes. So if you like things that begin with G, there's a G option, which is GTK based. Postmarket OS lets you run either upstream GNOME or lets you run FOSH, which is the Purism phone shell, which integrates nicely with GNOME. And then if you like things that begin with a K, there's a KDE stack, which is Plasma Mobile, which is also very good. And then there's a couple which are also Qt based but are independent. So the KDE Plasma Mobile thing uses KDE libraries. Sailfish OS is something from scratch. One of the original open source phone OSs, actually, even older than Android, I think. And Ubuntu Touch or Lemiri as well is an option, which is also Qt based. So is anyone running a G based phone? Ah, fantastic. Amazing. That's more than I expected, actually. So there are many reasons you should try it. Mainly that you want to have fun, I think. You don't have to write any C++ code, which for me is a big plus as well. You can use it to make phone calls. I have the honor of receiving, I don't know if it was the first phone call, but one of the earliest phone calls made from GNOME in 2018. That's my colleague Bob, and he successfully phoned me from a Librem 5 while in Spain. So you can use it to make phone calls. And it's very volunteer-driven development, let's say. There's not a huge amount of investment going into the GNOME phone stack at the moment. So you get to help out and be part of the QA team. A lot of good stuff happened over the last 6 or 7 years. GNOME obviously dates from before the smartphone even existed, so the original designs didn't even consider the idea of having a tiny vertical screen. And a few people have done excellent work adapting GTK and building what began as libhandy and is now libadwaita, which gives you, in short, it gives you adaptable widgets. So that's a really simple example, right? If the screen is wide, everything fits on the screen, and then the same app, if the screen is narrow, bits disappear and the buttons appear vertically so that it fits on a phone screen. And libadwaita is also the core of a lot of GNOME apps. It's quite new, so GNOME core app developers have rewritten their apps to use libadwaita, and it's the recommended way to build GNOME apps these days. So as long as you use libadwaita and you make a GNOME app, you kind of get adaptivity more or less for free. It's not quite for free because you have to test it, but you get it more or less for free. You don't have to maintain two different code paths. On the shell side, GNOME Shell does work in progress to make it phone adaptable. Not a lot of it's merged yet. Well, there's also FOSH that I mentioned before. That there's a fork. No, it's not a fork of GNOME Shell, is it? I'm lying. But FOSH also integrates nicely with GNOME and is built on the same stack. So there's a lot of good stuff, but we still have the problem that end users are doing a lot of the QA, right? I mean, do you find GNOME phone users, do you find any bugs? 1 or 2 bugs, maybe. So we're still not fully there in terms of testing, neither in the desktop world nor in the phone world. On the desktop side, the last 10 or 12 years, there's been some innovation. The big win has been openQA, which is a tool that began at OpenSUSE, and it's now used by several of the major distros. So OpenSUSE, Debian, and Fedora are all testing with openQA. And the great thing about openQA is it's an end-to-end test, so it actually boots the full operating system in a virtual machine and interacts with it like an end user would. So it sends keyboard events, and it reads the screen output and does image matching to check that the rendering actually works. So that's very different from a unit test where you mock the rendering pipeline and you mock the keyboard and you mock more or less everything, and then you test that your mocks work. And they do, which is great, but then in the real world, you integrate things together and it doesn't. So end-to-end testing is fantastic, but it's also kind of the most difficult and awkward to do because you are testing everything in a VM. So it's quite heavyweight. So in 2021, we set up a simple openQA instance for GNOME, and I did a talk on that last year or the year before, so I won't go over that again. But then last year, we ran an internship. These are two interns that we had, Dorothy and Tanju, and they looked at adding a few different tests. One of them they looked at was adding a test for mobile form factor. And when I scoped this, I thought, how hard can it be, right? You just make the screen smaller, and it'll just work. So, firstly, if you set the screen size very small, or rather, if you set the screen size to a number that isn't a multiple of 16, then openQA breaks, because it'll only encode the video if the resolution's a multiple of 16. So that didn't work. So we thought, okay, we'll work around that by setting the screen to double the size, which is actually closer to how a phone works anyway. I'll go into that in a bit. And we'll set 2 times scaling. Guess what? That doesn't work, because Mutter, the compositor that backs GNOME Shell, has a hard-coded limitation that it won't do scaling unless the screen is a certain size, which I guess the mobile forks are working around that, but we're testing the upstream version, and we were limited to that at the time, so couldn't work around that either. So we thought, well, what if we do a hack inside the OS, and we pass in some stuff to say, I'm a phone? That didn't work either. So we did add a mobile test suite in the end. I'll show you how that works. I want to show you a little bit what's remaining to do. What are the next steps? Because my aim for this talk is to make you interested in fixing some of these issues so that you don't have to be the test department anymore, and we can automate it better. So the first question is pixel density. This took me a while to wrap my head around, actually. But it turns out that most desktop monitors, I think this is true, are around 100 dpi. So for every inch, unfortunately it's in inches, for every inch of screen you have about 100 pixels taking up space. For example, if you have a monitor that's, this is a 24-inch monitor, my example up there, and so the width is 20 inches, the X resolution it would be designed for is 1920 pixels, and if you divide that by 20 you get 96 dpi. On a phone, you don't get that. So on a phone, the screen is usually much more dense. There's an example here that I got from my colleague Adrian, who... Actually, Adrian did most of this work. I should credit Adrian with doing most of the investigations I'm going to talk about. He couldn't be here today, but thanks to Adrian for doing all of this. So, for example, you look at the Librem 5. Actually, the UI is scaled by 2. And the way you do this in the real world is you'd set a display descriptor called an edid, and you'd put in the physical width and height of the screen, and then the rendering pipeline would say, we need to have twice as many pixels, right, because the screen is this size. So QEMU at the moment just hard codes 100 dpi. You can't set the screen width and height on the command line. It just guesses what it is. Whatever the X resolution is, it fakes a width based on 100 dpi. So that would be really nice to fix, right? It sounds easy to fix. Does anyone here work on QEMU? Fantastic. Does anyone want to work on QEMU? It's a very friendly project, right? Lots of people happy to review patches. So it's a great first patch if you want to work on this. Adding width and height parameters to the display, and then we'll be able to simulate a phone screen much more accurately. The next thing, the SM BIOS, which is some data structures that exist usually in hardware, and they pass information into the operating system of different types. The SM BIOS has a field called the chassis type, which lets you say, oh, this is a server or this is a handheld device. And there's some code in GNOME at the moment that changes behavior based on this value. I think it doesn't give you power saving warnings if you're on a handheld device, something like that. So that would be really useful if we could set that in QEMU as well. And again, we're almost there, right? It already has a flag to pass in SM BIOS type 3. We can set the manufacturer, set the version, but we can't set the chassis type yet. So this is another great opportunity to contribute. What else is needed? So to get this to where we can fully test how people really use a phone, QEMU patches are probably the low-hanging fruit, I would say. We also need to think about how to do multi-touch gesture input. openQA doesn't have any support for that at the moment, and it's maybe a little bit more complicated because we have to think how to record and play back gestures. I think the QEMU bits are there, but making it work nicely in a way that it's nice to author tests is not there. So that sounds like a fun project. And then the end goal, which would be fantastic, is actually testing on hardware, having a hardware rig. This requires people who want to host and maintain a board farm over time, which is also really fun. So that's something, I don't know how we're going to make this happen. It's going to require investment, right? Probably from companies that are willing to host these. It's going to be difficult if they're hosted in people's bedrooms. But in the long run, I would love it if we have hardware farms distributed around different companies that work in embedded and work in this space. And we can actually run tests upstream on real phones and say, this commit in whatever library has broken this device. That would be the dream. For more stuff about testing, I'm doing a talk tomorrow afternoon as well in the distros dev room. And I never told you how the test suite works at the moment. So we did get something to work. This is running right now in the GNOME openQA instance. And what we do, it's a little bit dirty. What we do is we boot the machine in desktop form factor, and then we run some JavaScript code in GNOME Shell to resize the window so that it's the size that it would be on a phone screen, and then we take a screenshot of that. So it is testing the adaptive code paths in libadwaita, at least, but it's not what I envisaged when we started work on the test suite. I hoped we'd get a little bit further than this. Maybe we will this year, still early in the year. But we are testing stuff at least, so we've made some progress. My contribution to this, I don't have too much time to dedicate to it, but my contribution is trying to get people to talk to each other, which I think is one of the hardest problems in software. So I run a monthly call that takes place once a month, happens 1 month. The details are in this wiki page, or if you search for, that's quite a long URL, isn't it? If you take a screenshot, then later you'll be able to see to visit the page. 1 minute. So it takes place alternate European mornings and alternate European afternoons, so that people in Asia can participate and people in the US can participate. And the idea is to break down the walls between distros and upstreams and different companies maintaining test suites and just talk about how can we make really good tests, how can we improve openQA, and so on. So please join that if you're interested. Come find me after and I can give you more details. And also, of course, there's the FOSS on mobile devices dev room, I'm sure you spotted, which is this afternoon. So join that as well. Thanks to everyone that worked on this. And that's everything from me. With 19 seconds left. Thank you very much for watching.